Okay, so we are simplifying radicals today, and here, this is a screenshot from the book on how you know things are simplified all the way. For example, you can't have a radical that's not broken down all the way. If there's something that you should pull out, you want to pull that out. Question A, we can simplify. The same way we did it when we had square roots, we're going to do this with cube roots. So you're going to start by finding two things that multiply together to give you 135. But the first one needs to be a perfect cube. So if you do not remember your perfect cubes, then make a list off to the side. Like 2 cubed is 8. 3 cubed is 27, 4 cubed, 64, 5 cubed, 125. What goes into 135 evenly from the cube list, if anything?
No. No.
So this would be the only thing we might need a calculator for today. Trevor, you got 27? How many times, Trevor? 5 times. So we're going to take that 135 and say that is the same thing as 27 multiplied by 5. And 27 is a cube that we know the answer to. 3. The cube root of 5, I don't know the answer to. So I write it next to the 3. And then it is in simplest form. So we have done this before with square roots. Now we're doing it with cube roots and other roots.
Whoa.
Okay, question B. Gets confusing because sometimes you want to do it one way and sometimes you want to do it a different way. Right, so you kind of like have to know what to look for. So one thing that I could try would be, since both of these are both fifth roots, I could try doing the fifth root of 7/8. But I don't even know what to do there, because 7 isn't a perfect fifth root. 8 doesn't have a fifth root that goes into it. 7 over 8 does not reduce. So doing this is not helpful at this moment.
Yeah.
But sometimes it is helpful. I'll show you an example where it is helpful. It's not helpful here, so I'm going to erase. No, it is helpful. It will be helpful. So my other option would be to take everything down to primes, to powers, the thing that we did a few days ago. We're going to take all the numbers under the radicals and write them as primes to a power. So 7, is that a prime number? 7 a prime number? Yes. Okay, so I'm not going to do anything with that one. I'm going to leave it as is. Eight, is that a prime number?
No.
No. So I'm going to take 8, and I'm going to write it as what to the what? 2 to the third. All right?
Yeah.
So write it as primes. Now the reason why I did that is because when you have a radical in the denominator, it is not simplified. I need to get rid of the radical in the denominator. You're not allowed to leave a radical in the denominator. So what we've done in the past, because we have had this already, what we've done in the past is we had to do what's called rationalizing. You had to multiply the top and the bottom by something that will get rid of the radical in the denominator. What we want to do here is think off to the side. If I rewrote this as 2 to the third fifths, 3 fifths, remember we can rewrite it that way? What I want to do is I want this to be a whole number. I don't want it to be a fractional number. I want it to be a whole number. Right now it's 3 fifths. How many fifths is a whole, I need it to be 5/5. I need it to be 5/5. That's what I need. So right now I have 3 2s here. How many more 2s should I give it to make it a whole?
Two.
So we're going to do the 5th root of 2 to the 2. But if you do it on the bottom, I don't know what just happened there. If you do it on the bottom, you have to do the exact same thing on the top because we're really not changing the value of this purple fraction, but we're just changing the appearance by multiplying by 1. This is 1. All right, how do we multiply fractions?
Use clock there, just moving across.
Straight across. And when we multiply straight across, these are both the 5th roots, so I can multiply the numbers underneath the 5th root. On the bottom, these are both the 5th roots, so I can multiply underneath 2 to the 3rd times 2 to the 2nd. I'm going to simplify the top. You have to do order of operations. So we got to do 2 squared first, then multiply by 7. So 2 squared is 4 times 7 is 5th root of 28. Then on the bottom, we're multiplying same bases. So what do we do? The exponents. We add them. So I will have the 5th root of 2 to the 5th on the bottom. And again, remember, if we have a radical, we can write it as a fractional exponent if we want. We can write this as 2 to the 5/5. And what 2 to the 5/5? Just 2 to the 1st. So I have one more step to rewrite it as the 5th root of 28 over 2. To the 1st. We had to do all that work because we are not allowed to leave a radical in the denominator. So you had to get rid of that radical. That's why we did all of that work. So now we do not have a radical in our denominator. The original question was what? 5th root of 7. Oh, not the directions. Not the directions. I'm at the 5th root of 7 over the 5th root of 8. These two are completely equivalent. If I type that in my calculator and hit enter, or type this one in my calculator and hit enter, they'd be the same decimal. They just look completely different, but they are equal. Okay? Number 5, 6, 7, 8. I'm going to give you a moment to try them, any of them, and then we are going to go over those together on the video. I'm going to give you a moment to start. One thing you should not be doing is only using your calculator. You can multiply 27 times 3 if you need to. But other than that, I don't want you to type in the 4th root of 27 times 3. Like, I don't want you to type in. Can you try any of them? I'm going to go over all of them. Yeah, just, do you need it the second? You can leave it plugged in up here until you're ready to use it. It's sitting on my desk. Remember how I was saying sometimes learn to say that sometimes. Yep. Remember that? All right. Pause where you are. hard, because I want to make sure you don't do way too much work for number 6. I just want to make sure you don't do way too much work for number 6. Let's do 5. These are both the fourth root, so did you multiply them together? You get 81.
Yeah.
And then you're like, ooh, is the fourth root of 81 an actual number? It is. 3 to the fourth is 81, so the answer is 3.
Does it have to be plus minus?
Because you didn't put in the radical yourself. That's only when you do it, when you put it in. All right, number 6. If they are the same radical, we can try to divide them. It didn't work on the example right above it, but what happens when I try to divide 250 and 2? I get 125. So the third root of 125 is 5. So that's what I was trying to tell you before. Sometimes it helps to divide it, and sometimes it doesn't help to divide it. Okay, so number 7. That one is just cube root of 104. And that 104 is not in our perfect cube list. But what number is on our perfect cube list goes into 104, divided into 104. We made that perfect cube list today. What was it? Has to be a perfect cube. What did you write down, Colin, right above it? 8. Yeah. Cube root of 8 and the cube root of 13. Once you've divided 104 into 8 times 13, after that, that's when you take the cube root and get 2. Cube root 13. Number 8. Does 3 divided by 4 divide evenly? No, it does not. So this would be the kind where we're going to have to separate it. And then write as primes, powers, anything I can. Is anything in here? On the bottom, that's a cube root of 2 squared. On the top, oh, not cube root, it's fifth root, sorry. Handwriting, gotta get better at that. On the top, fifth root of 3. So we're trying to make whole on the bottom. We're trying to make it whole. And if you look, we have sometimes it's easier to see it if you turn it into a fraction. 2 to the 2 fifths, the root is the 5. So how many do I need more from how many I have already? I have 2 fifths. How many more fifths do I need? How many more fifths do I need? 3. So you want to do fifth root of 2 to the 3 more. I'm doing 3 more 2's. Fifth root of 3 more 2's. So that we can get a total of 5 2's. So on top, I get the fifth root of 3 times 2 to the third. And on the bottom, I get the fifth root of 2 squared times 2 to the third. Be sure you are using order of operations on top. 3 times 2 to the third, you have to do 2 to the third first, which is 8 times 3, 24. On the bottom, I add my exponents, and I get the fifth root of 2 to the fifth. So on top, put 3 to 24, and then what do I get on the bottom? Sometimes it might help you to look at this being 2 to the 5 over 5. What do I get on the bottom? What do I get?
2.
Thank you. 2.
Shocker.
There are a lot of steps to learn, and it's only going to come from practice.
Yeah.
Correct practice.
Does that mean we have a lot of homework?
No, but we're still not done with our examples today.
How many questions do you have for homework?
I don't remember. Something. All right, the next one. In the directions, it has something highlighted. It's the word conjugate. And I hope you say, oh, I've heard that before, because I've said it in here quite a few times. When we were solving by factoring and we had zeros, we learned that if you have 1 0, that's like 7 plus square root 6, then there's actually 2 zeros because radicals always come in pairs. The other one is called its conjugate. Yeah, you just take the center sign, 7 minus radical 6 would be the conjugate. Or maybe there's -1 minus radical 5. What would be the conjugate of this one?
Plus 5.
It would still be -1, it would just be plus radical 5 instead. So it's only that middle sign that changes. Those are conjugates. The reason why we go over this is because when we have a radical in the denominator with another term, when there's a plus sign or a minus sign with it, you have to simplify it by multiplying by the conjugate. You have to multiply by its conjugate. I'm going to rewrite this question because it has other words there. They're in my way. I'm just rewriting the question right here. In order to simplify that, you have to multiply by its conjugate. So we're going to multiply by, what's the conjugate of 5 plus radical 3? 5 minus radical 3. And we do that on the top and the bottom so that it's really multiplying by a value of 1. There are understood parentheses here that you don't necessarily write, but you understand that they are there. I'm going to put them there because it's helpful to have them. There's understood parentheses here, here,
Here.
and here.
That's understood.
They're supposed to be understood. So on top, how do I multiply a number times 2 terms? What's that called?
Distribution.
Distribute. So 1 times 5 is 5, minus 1 times radical 3. On the bottom, how do I multiply 2 terms times 2 terms? Oil. If you know, then you that is correct. I'm going to pretend that you don't know. 5 times 5 is 25. Then outer is going to be minus 5 radical 3. Inner is going to be plus 5 radical 3. Last is going to be minus radical 9. So that was FOIL. Let me simplify. On top, I cannot subtract a whole number and a radical number. They are not like terms. So we leave it as 5 minus radical 3. On the bottom, I have 25, and what happens to minus 5 radical 3 and plus 5 radical 3? That should happen every time when you multiply by the conjugate. That's what the conjugates do. They are difference of squares, and they cancel out their middle 2 terms. The last term, minus, what's the square root of 9? So minus 3.
Which is 22.
Mm-hmm. Now, if this is simplified all the way, that means the radical can't be broken down anymore. Square root of 3, can I break that down anymore? No. I can't leave a negative in the denominator. Do we have a negative number in the denominator? No. Could I cancel out like a 5 and a 20? Can I cancel out 5 and 22? Like, there's nothing I can do else to this one. It is in simplest form. So that's how you get rid of the radical in the denominator when it has friends, when there's terms with it. So there's 2 more examples. Take a moment. What are you going to do first? And then I will work through this one with you.
Oh, that's a good question.
It's right next to it.
Oh,
Apparently I hit it very well. What are you going to multiply by? What are you going to multiply by? What did we multiply for this? What is it called that you are going to multiply by? What's it called? Your conjugate. You have to take what the denominator is and multiply by 1 minus radical 6 instead. And then I like to put in the parentheses that are there but not written. How am I going to multiply 1 term on top by 2 terms on top? Distribute. So I get radical 2 minus radical 12.
over.
What do we do on the bottom? FOIL. First is,
Distribute FOILs the way you distribute. Still distribute.
it is still the distributive property. Is that what you're saying?
Yeah.
Yeah, it's called the extended distributive property. 1 times 1, and then minus radical 6, and then plus radical 6, and then minus radical 36. And what happens to the center terms? They cancel out every time, if you've done it correctly. So I get 1 minus 6 on the bottom. On top, I've got radical 2 minus radical 12. On the bottom, I've got negative 5. And then I stop and say, is this simplified?
You still do.
Not allowed, well, I can have it, it's just not simplified.
That's illegal.
Because they're technically the same root number, could be 2 to 12. No. 2. Okay.
Thank you, I will say that though. Okay, so Jarrett is very unhappy that there is a negative in the denominator, so let's get rid of that. In order to get rid of that negative, you can multiply by -1, but it has to be -1 on the top and on the bottom, so you're really multiplying by +1, just in disguise, so it looks like it's a -1. Do you understand what I'm saying? Or,
I comprehend.
these are the same number, so we're really not changing the value of this. It's not like multiplying by 2. It's multiplying by a value that is 1. It just looks different. Negative radical 2 plus radical 12 over +5. Okay, so this is still not simplified. What were you going to say? Radical 12. Radical 12. So radical 12 is a has a perfect square in it. So we have to break radical 12 down.
It just keeps going on.
It does. So that's radical 4 times radical 3, which is 2 radical 3. So now we have negative radical 2 plus 2 radical 3 over 5.
Got anything else?
Okay, so in order to add together radicals, they have to be the same root, and the number underneath them also has to be the same. So they both have to be square root, which these are, but they have to be square root of the same number, which these are not. So I cannot add together radical 2 and radical 3, because they're not exactly the same root and same number. So this is as far as we can go.
Oh, fine.
About the same number, do you get the same number inside the radical or before?
Under the radical. The number in front of it doesn't matter, but under the radical. Okay, did you write down what you would multiply 9 by?
What?
Workout number 9.
Oh, the times you gave.
Workout number 9. We just did 2 full examples. Workout number 9. Now let's see. Brian, what'd you multiply by?
6 plus
Perfect. 6 plus radical 2 over 6 plus radical 2. All right, common mistakes that I've seen all day would be on top when you distribute. You cannot multiply together a number with a radical.
Yeah, so you use.
So you just put them next to each other with 3 radical 2. And then on the bottom, I'm doing FOIL very fast. So you get 18 plus 3 radical 2 over 34. And that's all you do. All right, moving on. Now, the last section we're doing today is adding or subtracting terms with radicals, adding or subtracting.
2 plus 2 is 4.
Okay, that's good, but that's not what we're doing. The first one is it the same index and the same number under the radical? That's what you need to check for. Same index, which is the same root. And the same number under the radical. Do we have that for question A? So what is the coefficient of this like term of the fourth root of 10? That coefficient is 1, and that coefficient is 7. So if I've got one of them and I got 7 more of them, then I have 8 fourth root 10. That's it.
See, simple addition.
Question B. I've got 2 8 to the 1/5 plus 10 8 to the 1/5. This is the like term. The number I find front is what I'm adding. So now I have 12 8 to the 1/5. Question C, do we have the same index number and the same number under the radical?
No.
What do we have?
The number under the brackets.
Okay, but does this simplify?
Oh.
8 doesn't go into 54. Has to be a perfect cube, but 8's not the one. No.
47.
Right, 27 goes into 54 2 times. So we're writing this, by the way, this is multiplication between these two things. Write it as cube root of 27, cube root of 2. And you say, what is the cube root of 27? What is it? 3. Bring down the cube root of 2. Bring down the minus sign. Bring down the cube root of 2. And now we have the exact same cube root, the exact same number underneath it. So we just take how many we have. 3 of them, subtract how many of them? 1 of them. We have 2 of them total. 2 of what? 2 cube root 2's. Okay, there's 3 U tries. There's 3 U tries, and I'm going to come around and check them off. When you get them, you can go get your computer. Right there. I just brought down the subtraction sign. I brought down that cube root of 2. Alright, so we've got 3 of them here. We've got 1 of them here. And we're done. We've got 2.
Oh, yeah.
So look at the ones that I just did. Look at 11. How did I do that one? You cannot add with the radical. You gotta do this one.
You done Sunday, I pulled the 175 and then.
That's like saying 4s plus
Yeah. My height was green.
you're gonna write that, look how I was writing the answer.
You can't. The highest that anyone could have.
First step. Well, what cube goes in the 8? Where's your list of cubes? Figure out what cube goes in the 8. Where's your list of cubes? Okay. Well, cubes to these on your Are you 6? So just give. See that one? So it doesn't fit back on top, so I can get it fit. So what for the third power can go in the So what is the key to that? I don't understand what you're saying. What times what?
Did you come to
Okay, the 2 or 20 is not a perfect cube. One of them has to be a perfect cube. what times what is 40? Bring it up. Start making a list or make 40. So you have to break down 40. Just like we worked out before. Figure out what is what makes 40. But one of them needs to be the perfect case study that's. So one of them has to be one of those numbers. If you got it, get checked out and start on your computer stuff. So you broke this down into 8 and 5. But what is the computer?
What is it that you find out?
Yeah, should be sure of that.
That's what I do.
That should be the key.
Is that all in here?
So now we have the same. Yes.
Like, I don't know, I like this.
Okay, I'll tell you what it is in the book then. Go grab a book, I'll be there on page for this. And then you can just do it on paper and then plug it into the book when it's, plug it into the envelope when it's there. Okay, so so then you need this plug that one over there.
Brandon, you don't even have to sign it open yet. What have you been doing?
So you just write 2 in front of them. Okay, and then bring down your book line here. Your radical or you can find that. So we've got how many computer defined? We've got 1 computer defined, and we've got 2 computer defined. So now we have 3 computer defined. The same kind of thing that we were doing for the first example today. Break it down. So the first one's gonna be a 4.
Oh, we moved it down into 40.
All right, Caleb, did you find the page?
Yeah.
How many questions are there? What does it say? How many questions?
17?
17, okay.
There we go. We got it. Yeah. It's pretty.
All of that section, 21, 22. So Caleb, the author of Dr. Book, so like they can check your. Tell me stop recording. Yeah, yesterday's video recorded like through class changed.
I reminded you to